two classes, nearly identical. I create an instance of the first one and just tack on a new attribute, and it works fine. I do the exact same thing on the second one, and Python throws an attribute error. Same syntax, same dot, completely different result. Something under the hood is deciding whether that's even allowed. That second object isn't buggy, it's following a rule you set on purpose. And by the end of this video, you'll know exactly what that rule is. I'm Kai. Welcome back to Fun with Learning Technology. If a random attribute error on a class that clearly has that attribute has ever confused you, or you wondered how a Django field or an act property just works, this is that answer. You don't need to know anything about Python C internals. We're staying at the language level, and you'll walk away having built two small working examples yourself. You write obj value. Python doesn't just grab it from a dict. It runs a search, first the type, then the instance, then the type again. Where it finds it, and what kind of thing it finds changes everything. Picture a front desk that intercepts your mail before it reaches your desk, opens it, maybe edits it, then hands it over. Some class attributes work the same way. They're objects carrying a getGets and agesHead method. Python routes every dot access through them first. That's the mechanism behind a property and every magic ORM field. Without this, you'd paste a value, 0, raise into every single place that touches balance across your code base, and the one time someone forgets, a negative balance slides through with no error. This class closes that gap in one place instead. The get method runs whenever someone reads balance and just hands back the stored value. The set method runs on every assignment. And this is the part that matters. Before storing anything, it checks for a negative number and refuses it. On the account class, balance isn't stored as a plain value anymore. It's swapped for an instance of this descriptor. So every assignment routes through that set method. Normally, every instance carries its own dict of attributes. That dict costs memory, multiplied by every object you create. Slots tells Python, skip the dict, use fixed slots instead. That's why the second object couldn't take a new attribute. There was no dict left to put it in. Here's the mistake people actually make. They slot a subclass and assume the memory savings carry through. But if it inherits from a class that doesn't define as slots, Python slots slots, Python slots slots, Python silently gives it a dict anyway. And the whole optimization is gone with no error to tell you. If you want the savings, every class in the chain has to opt in. Quick one before we move on. Say a class inherits from two parents, and both of them define a method with the exact same name. Which one actually runs when you call it? Take a guess and drop it in the comments, then we'll check it against what Python actually does. Now, inherit from two classes that both define the same method. Which one runs isn't a coin flip. Python builds one exact search order across the whole hierarchy, the MRO, called superAnywhere, and it walks that same order, not just the parent. Step back one more level, a class gets built too, the same way an instance does, just one level higher up. Whatever builds a class is called a metaclass. Override that metaclass and you control how every class using it gets assembled. All of that happens before a single instance of it exists. Registry is just a plain dict that'll hold every class we build. Meta subclass is type, because type is the default metaclass, and this new method is where the actual class object gets built. First, we let the normal machinery build the class like it always would. Then, before returning it, we drop it into the registry keyed by its name. Now look at plugin. It doesn't call any registration function itself. It just declares this metaclass. And CSV plugin inherits that metaclass automatically. So the moment it's defined, it's already in the registry. Nobody had to remember to write that line. Obj.attr walks the MRO through descriptors. LotStore decides whether there's even a dict to fall into. And a metaclass decided how the whole class got built before any of that ran. 4 separate mechanisms, one underlying idea. Attribute access in Python is a protocol, not a fixed rule. That's why the object at the start rejected a new attribute. It had no dict left, exactly as slot specified. Next time a framework does something that looks like magic, check which of these 4 hooks it's actually using. Daily uploads, same channel. Subscribe if you want to catch them as they land.